Hello everyone, in this video we are going to see about the load balancer in cloud computing. Let us first define what is a load balancer. Load balancer is defined as a networking device or software application that distributes and balances the incoming traffic among the servers to provide high availability, efficient utilization of servers and high performance. Here this it may be a hardware or a software, and it helps to distribute the load, that is incoming traffic as the data comes inside the network, and this load balancers helps to distribute them in an efficient manner so that it will give the high availability, means the data is available to all the servers and the utilization of server is very efficient and for the high performance. A load balancer works as a traffic cop sitting in front of your server and routing client requests across all the servers. So here the traffic, that is the data, comes in and out, and his load balancer, it works as a traffic police which who will control the traffic across the roads. Here this load balancer controls the traffic across the servers. It simply distributes the set of requested operations, that may be a database write request, cache queries. Cache queries are nothing but we are having some data in the cache memory, and that can be queried. That means that can be questioned with any queries effectively across multiple servers, and ensures that no single server bears too many requests that lead to degrading the overall performance of the application. So it regulates the traffic across the servers. That is it works like a traffic police who controls the traffic on the road. This is a diagram for this load balancer, and this is the load balancer which is in between the internet and the servers. And the servers, there are many servers are there. For example, they are given the group 1 which is having the blog, and group 2 some root directory, and some group 3 for forums, and some examples are given here. And this is the client, the user who is going to access the servers, and in between the client request and the server's response we have a load balancer, and this is going to balance the load or the data across the servers in an efficient manner. Load balancers are highly used in cloud computing domains, data centers, and large scale web applications where traffic flow needs to be managed. And the primary goal of using a load balancer is not to overburden with the huge incoming traffic, which may lead to server crashes or high latency. Sometimes if data comes in and out of the server in a heavy manner, sometimes the server crashes, or there will be much delay. There is a latency, means a delay. There may be much delay in the traffic of the data. So the primary goal is to balance the load, that means not to overburden the incoming traffic of any server. And load balancers perform a range of specialized runtime work distribution functions that include asymmetric distribution. That means larger workloads are issued to IT resources with higher processing capacities. So whichever the server can perform which having the higher capacities, they will be given the larger workloads. That is called as an asymmetric distribution. It is then asymmetric is opposite, so it is not distributed in a similar manner, because heavy workloads are given to heavy processor capacities. Workload prioritization. How to prioritize the workload? It depends upon the workloads are how it is scheduled, how it is queued, discarded, and distributed workloads according to their priority levels. So based on the importance of the work may be scheduled or queued or discarded or distributed. That means sometimes they schedule the work for some time later, and sometimes they will be asked to be in the queue, and sometimes they will be discarded for some time. So this is the way the workload are prioritized, whether the workload has to be given the importance or not. And if so when to give the importance, that is the scheduling or queuing. And the third function is it gives the content aware distribution. These requests are distributed to different IT resources as dictated by the requested content. So whichever content suits whichever server, accordingly the data are distributed. The common objectives of using load balancers are: number one, to maintain system firmness. That means the system is always firm, in the sense the system is always able to accept or instead balance the work being given. To improve the system performance, that is to speed up the system or to give the efficient data in an expected time, that is the system performance. And to protect against the system failures. So suppose if the load is heavier, it may cause the system to fail. So these load balancers helps to avoid the system failures. And the few more key characteristics of the load balancers are the traffic distribution. Load balancers evenly distribute incoming requests among the multiple servers, preventing any single server from being overloaded. So the traffic is distributed evenly to all the servers, so that no single server will be suffering from heavy load. Next is the high availability. By distributing the traffic across the multiple servers, load balancers enhance the availability and reliability of the application. That means if one server fails, the load balancer redirects the traffic to the healthy server. So suppose if a server has some problem or some issues, it is expected to fail. In that case, these load balancers enhances the availability by redirecting the traffic to the healthy servers. That means the server which are very active. Next is the scalability. Load balancers facilitate horizontal scaling by easily accommodating new servers or resources to handle the increasing traffic demands. So as when the demand is increasing, the load balancers distribute the load or the data horizontal manner, that is the horizontal scaling. And few more characteristics are optimization. Load balancers optimize resource utilization, ensuring efficient use of server capacity and preventing bottlenecks. So bottlenecks are the troubles which will just prevent the traffic flowing. So now these load balancers optimizes the resources utilization. So how to use the resource in an efficient manner and to ensure the server capacity. That means it should not give an overload to the server, and also the traffic should not be stopped anywhere in the flow of the data, that is the bottlenecks. And the next is the health monitoring. Load balancers often monitor the health of the servers, directing traffic away from servers experiencing the issues or downtime. If at all some server is expected to fail or facing some issues in that time, these load balancers keep on monitoring the health of the servers, and it will try to direct the traffic away from the unhealthy situation of the server. That means there may be some downtime, the server may have some problem. In that case, traffic will not be forwarded to the unhealthy server, that is the health monitoring. And then SSL termination. Some load balancers can handle SSL, that is the service socket layer, and security socket layer, and this is the transport layer service encryption and decryption, offloading this resource intensive task from servers, because sometimes the data has to be encrypted or decrypted in the sending side or receiving side. That means data has to be secured by the additional technology called the encryption or decryption. In that case, these load balancers handle this type of encryption work, so that it reduces the task of the server. In that case, the server can work efficiently. And the load balancer mechanisms can exist as in different form: multi-layer network switch, or it may be in the dedicated hardware appliances, or it may be a dedicated software based system, or it may be a service agent. So these are the four different ways the load balancer can be implemented. So it may be a network switch, that means we have multi-level layers where we can apply the load balancer, or sometimes it will be a individual device, hardware device, or sometimes it will be a software based system, and sometimes we can get those load balancer as a service. Like how we get a software as a service, platform as a service, the same we can also get the load balancer as a service. So that's all. These are types of the load balancers. They are hardware, software load balancers, hardware load balancers, and virtual load balancers. Virtual load balancers are the load balancers which is got as an agent. Okay, so that's all the concept of load balancers. Hope it is easy and simple to follow, and thanks for watching.